So we will wrap up this short chapter, which is just an introduction, with the last cluster. The sixth cluster is the ecosystem management cluster, which I talked about in a little bit of detail before. So this is another infographic from this Pinterest, which is from I think World Wildlife Fund anyways. It's talking about deforestation and forest degradation representing 20% of all CO2 emissions, more than the entire global transport sector, which only accounts for 13%. So deforestation and forest degradation are serious contributors which should motivate the ecosystem management cluster solidly. There is an initiative under UNFCCC called RED, Reduced Emissions from Deforestation and Forest Degradation, where there are a number of solutions, monitoring incentives are set up. Solution number 10 under this, the last of the 10 solutions, says regenerate damaged natural ecosystems and restore soil organic carbon to improve natural sinks for carbon through afforestation, reducing deforestation, and reforestation, restoration of soil organic carbon. This is seriously underestimated, especially in countries like India, where soil degradation and soil erosion are serious problems, especially with extreme events increasing, okay, and bad agricultural practices as well. Like tillage and so on. Implement food waste reduction programs and energy recovery systems to maximize utilization of food produced and recover energy from food that is not consumed. We have read these before, but let's read it again just to re-emphasize in our head. This is a nice graphic from this paper on food waste and source collection, agricultural and commercial areas, residential areas, transportation loss, emissions from landfills, so leachates and odor, methane, ammonium, H2S, which is a stinky gas, hydrogen sulfide, carbon dioxide, of course, N2O, which is a very strong greenhouse gas, carbon monoxide, which is a poison, and of course water, which is a hydrogen, which is not good either for health. Processing and treatments, amendments and additives are added to reduce the emissions. So biochars, which are basically converting these into carbon that can be sprinkled on soil to increase carbon content of the soils, which is actually very good for yield, increasing yield. Negative compression aeration to remove ammonium, corn stalks and food wastes. So there is emission of ammonium, methane and N2O out of these. Applications: increase soil property, soil health if you will, increase plant productivity and supply nutrients. Okay, so this is under ecosystem management that can work and is working in many places. There are many private companies in recycling garbage now or producing energy out of garbage as well. Okay, what are living laboratories? This is a good example from this Monash University website. This is the civil engineering department, and civil engineers want to talk about reducing energy used by the buildings, for example, and you can see that these kind of vertical vegetation, vertical gardening, and there is also vertical farming, urban farming and so on now, and you can see that this is what is called a living laboratory. There are nice examples as well at the Nanyang Technology University in Singapore, where its library's got a nice green roof, which I think is carbon neutral, if I'm not mistaken, but you can look up. So these are examples where the goals of the education is implemented locally in the way they do things themselves. So they become living laboratories of education itself. Okay, so the other example is cities as living laboratories, a framework for 21st century city from this organization here, Uranio. Urban renewal and something something. Social sustainability, environmental sustainability, and economic sustainability includes artists, scientists, poets, engineers, sociologists, performers, historians, and designers, all working together, collaborating and producing cities as living laboratories. Fantastic concept and implemented in parts in various places. And if you're not already clear on this by now, climate change is a natural science problem in terms of the causes and impacts, some of the impacts. But all the solutions, there is technology cluster, there is a science pathway, but the rest of it is all about social science, arts, poetry, performance, and so on. So that's something we must find a way to work together. The C40 that we talked about before, these are the member cities. We already looked at how they have grown in number, in implementation of solutions, in reducing emissions, improving air quality, and so on and so forth. So basically all continents now have, except Greenland of course and Antarctica, have cities which are members of the C40. This is the expansion of the living laboratories to a global scale. Okay, so are we certainly headed in the right direction? In many ways, yes, but obviously much more needs to be done. Here around the world, cities are prioritizing different actions. This is from CDPnet, showing key to actions: energy supply, waste management, outdoor lighting, citywide planning, water management, mobility, in terms of reducing emissions as well as providing access, equitable access, building energy use, and so on. So you can see that all these C40s are taking action and participating. Global cities are stepping up on climate action. The shift to low carbon economy is underway. Cities worldwide are stepping up to tackle dangerous climate change. Climate disruption and dangerous climate change and dangerous climate interference are all these interchangeably used terminologies. With increasing extreme weather events worldwide, cities are aware of the climate risks they face. Urban risks are quite different in many ways. And are taking vital actions to reduce emissions. In light of the recent IPCC report, we know that urgent action is needed to limit warming to 1.5 degrees centigrade. Cities are taking action. You can click on these links to find them, to combat climate change today, and are planning for the future through ambitious target setting and forward action planning. Here are again the details from California's climate strategy, a living laboratory as a state, integrated plan for addressing climate change, reducing greenhouse gas emissions to 40% below 1990 by 2030. That's by the state. So it doesn't matter what the federal government is tinkering with and struggling with in terms of political consensus and different political lobbies and pressures. States, especially New York and California, which are rich, Washington, which is very progressive, can do on their own. So they're focusing on renewable electricity, use of vehicles, buildings, retrofitting as well, carbon sequestration by afforestation and so on, reducing short-lived climate pollutants, and protecting California. So California's climate targets include 2020, 2030, 2050 horizons. 2020 is not a horizon anymore. We are already here and almost ending. Return to 1990 levels, so electricity from renewables reduce from 1990 levels by 100% by 2045. And these are the C40 members that we already talked about. Okay, 97 member cities, 700 plus million citizens, 1/4 of the global economy. Cities are economic hubs. Okay, all these numbers are truly impressive. Like, for example, 17 C40 cities have restrictions on high polluting vehicles that cover a significant part of the city compared to 6 in 2010. Parking regulations, alternative days of driving into the city, and so on. So the system itself is not set up to completely eliminate driving, for example. Public transportation may be not able to serve everybody, especially poor people. So you will need a car. Then the question is, how do you manage the cities? 82 of the C40 cities have implemented cycle hire schemes compared to 21 in 2010. So all these numbers are really impressive. Within California itself, you see San Diego has its own action plan, carbon neutrality, San Diego's goals, mitigation strategies, depending on building efficiencies, behavior and institutional change, campus fleet, space utilization, commuter options, and renewable energy. So, exciting, right? I feel better about solutions that are well defined and have living laboratories which are already implementing them than looking at what is working and growing them, and widening them becomes much easier. So that ends the chapter on a high note, I hope.